Hi there. Today you're going to learn how to solve a quadratic equation. If you're really good at factoring, solving it by factoring is super easy. Here we go. Just to remind you that when a graph crosses the x-axis, that's a solution. The other names would be roots and zeros and the x-intercepts. Be sure to know all four names for when a graph crosses the x-axis. When we identify a solution from a graph, we just look where it crosses the x-axis. So as you can see in example 1, it crosses here at -3 and again at 2. So since it's just one graph, it's perfectly acceptable to just write the solutions in squigglies. So -3, 2 would be the solution set for that one. In example 2, notice the graph only touches just once on the x-axis. So the solution for this thing would just be 5. But since it's a quadratic, we know we have to have two solutions. That's why 5 is called the double root. And this is going to come up again in just a little bit. But again, when it crosses just once, it touches and then bounces back up again like it does here. So if it bounces and then bounces back up again, that's a double root because it just touches once. Okay, so let's talk about solving them. Here we go. Remember that a factor, right, is split up. It's multiplication of two expressions, so it has parentheses. The solution for x is the number. You have to set the factors to 0 to find example. For the first one, if x minus 3 is the factor, then you just set x minus 3, equal to 0. And when you solve, x is equal to 3, because you just add 3 to both sides. Let's go backwards. If the solution was 6, if you just add 6 to both sides, then you got x plus 6 was the 0, so your factor was x plus 6. Now, do you see a pattern here? When you have inside the parentheses a negative, it's the opposite on the solution. Again, when it's positive, it's a negative in the solution. And this is why I bring up pull out opposites in parentheses, or just poop. And then you'll find the solutions to those factors. Just pull out the opposites. So here's a good one, right? What do you do if you have that number in front? Well, let's set that equal to 0. So 2x is -7. X is -7/2. If you remember, when we were doing slip and slide, the 2 came from the bottom, right? So remember, we brought the 2 up to the front. So if we just worked our way backwards, the 2 just comes right back underneath the 7. And since it's a plus 7, then the solution is -7/2. So you just divide by that first number. In the next one, the solution was positive 3/4. So since it's positive, we know it's going to be a minus. The 3 is what you're subtracting by, and the 4 comes back in front of the x. Right? If you're not sure how to do that, again, all you have to do is just just subtract 3/4 from both sides. So x minus 3/4 is the 0. Again, the 4 comes up, and that's why it's 4x minus 3. What about a factor of 2x? Well, this is the best one. Here we go. If there's no parentheses and the factor is just an x with no pluses or minus, you just set 2x equal to 0. And the only way that can be 0 is if x is 0. So if it's just a factor of x and no addition or subtraction, then x is 0. It means it crosses the x-axis at 0. Okay? All right, so I'm going to factor these quite quickly. You're going to have to look back at the other videos, the other lessons to see how to factor. But now that you know how to factor, finding the solutions are super easy. For example, to solve by factoring, the first thing you want to do is set this equal to 0, and then factor. You know from previous lessons that this is going to be x plus 1 and x plus 3. So if you just pull out the opposite, this one is x is -1, and this one will be x equals -3. Why is that, Miss Fleck? Well, if you put in -1 into the first solution, If you put a -1 here, that becomes, this whole thing becomes 0, and then 0 times anything is just 0. So basically, we're just giving it both cases where the answer will be 0, but being that one of the factors is a 0. All right, for this one again, for the y, just set y equals 0. Factor, you got x, and x. 7 times 4 is 28. Positive 7 minus 4 is 3. Therefore, x equals -7 and x equals +4. Let me step back real quick. Showed you how to find the x's. So the final solution is -1, -3 in parentheses, or in squiggles. Right? So on this one, it's -7, 4, squiggle, squiggle. Example 5 is an interesting one. Here we go. If you were to break this up, again, set it equal to 0. X and x. 2 and 2 make 4. Notice again, we have a double root. In other words, the answer is the same for both of them. So therefore, there is only one answer. For both of these, x is just +2. So your solution is just 2. In example 6, 25 and 16 should look really familiar. Those are squares, so we have dos, difference of squares. So we have 5x, 5x, 4, and 4. We know one is positive, we know one is negative. It's already set equal to 0. So again, just pull out the opposite. If there's a number in the front like that 5, it just goes underneath that 4. So x is equal to -4/5 for the first one, and x is equal to +4/5 for the next one. So -4/5 and +4/5 is your solution. For example 7, for all of them, you have to be looking for the greatest common factor. In all of the work that I assign you, the GCF always comes first. So make sure you GCF before you try any other factoring method. Over here, we have a GCF of 2. So if you pull out the 2, you're left with x squared plus 3x minus 18. Keep that GCF, it's there. Obviously, it's not one of the factors because 2 times something won't make it a 0. The zeros have to come from the factors. So the 2 factor into x minus 6 and x plus 3. Right? And since 2 can't be 0, then this has to be a 0, so that means x has to be 6. Or this has to be 0, or x is -3. So again, only 2 solutions, 6 and -3. Remember that we're working with quadratics, and that's always just 2 solutions. So if you think there's 3, think again. Here we go. Well, in example 8, it's not set equal to 0. So the easiest thing to do is you want to kind of keep that x squared positive. So we're going to move all of this to the other side via subtraction or addition for the -10x. So set equals 0, this becomes 3x squared plus 10x minus 8 equals 0. We're checking for a GCF. There is none. There's a number in the front, so slip and slide. Slip the 3 to the back, multiply it to the 8. X squared plus 10x equals, or minus 24 is 0. Factor that expression, xx. 12 and 2 give you 24. Positive 12 and -2 give you 10. But don't forget to slide out that 3. It's hidden. It's hidden in the 12. It's hidden in the 2. Reduce where you can. So it's x plus 4. And if you can't, just bring it back up to the front. So 3x minus 2 is equal to 0. So that first one gives you a solution of x is -4. And the second one is x is equal to positive 2/3. So -4 and 2/3 are where the graph crosses the axis. Okay, For number 19, again, make sure you set it equal to 0. I'm going to go ahead and move everything to the left side. So 12x squared minus 28x minus 24 is equal to 0. And you ask yourself, self, is there a GCF? Well, yes, there is. The GCF is 4. So if you pull out a 4, then you get 3x squared minus 7x minus 6 is equal to 0. There's a 3 in the front, so slip and slide. Move the 3 to the back. Keep that 4 out there. X squared minus 7x minus 18 is now factorable. So x and x. To get 18, that's 9 and 2. To get negative 7, it's negative 9 and positive 2. Remember, though, the 3 is hidden in the 9 and in the 2. So this becomes 4, x minus 3, 3x plus 2 equals 0. And again, poop, x equals 3, x equals negative 2/3. And those are your solutions. All right, let's try one more. Here we go in example 10. Oh no, there's only 2 pieces to it. No big deal. Just set it equal to 0 again. Move the 10x to the left, so you have 4x squared minus plus 10x is equal to 0. As you can see, this thing has a GCF of 2x. So if you pull out 2x, then you get 2x plus 5. Sorry, 2x plus 5 is a 0. And if you'll remember from the front part of the notes, if you just have an x with no pluses or minuses, then one of your solutions has to be 0. For the second one, poop, negative 5/2. So the solution to this thing is 0, negative 5/2. I hope that was clear. If it wasn't, please let me know. I will be around on Remind 101, and yeah, good luck. I'll see you when I see you.